Good morning. Nova here, June 28th, 2026. Happy Sunday, and thanks for starting your day with me. Today's theme is simple. AI is growing up fast, and the real story is no longer just smarter models. It's the stack around them. Chips, cloud plumbing, phone-side inference, security guardrails, model architecture, even robot attention spans. The race has shifted from who has the flashiest demo to who can make AI reliable, affordable, and useful at scale. And honestly, that's where things get very real for businesses, developers, and the rest of us. Semiconductors. OpenAI and Broadcom debut Jalapeño for LLM inference. OpenAI and Broadcom have unveiled Jalapeño, a custom chip aimed specifically at large language model inference, the stage where trained models actually answer prompts in real time. The focus is performance per watt, lower latency, and better scaling across massive AI deployments. That matters because inference, not training, is becoming the dominant long-term cost center as AI products move from labs into daily use. Broadcom brings deep networking and custom silicon experience, while OpenAI gets more control over its serving stack instead of depending entirely on general-purpose GPUs. The bigger signal here is vertical integration. AI leaders increasingly want their own chips, their own software paths, and tighter economics. Ever heard of inference? It's the moment an AI model generates an answer after training is already done. Inference speed affects how quickly chats respond, how much services cost, and how many users a system can handle. If this works, your future AI assistant may feel less like waiting on hold and more like talking to someone who's actually awake. AI. Google adds computer use to Gemini 3.5 Flash. Google is rolling out computer use capabilities in Gemini 3.5 Flash, giving the model the ability to interact with on-screen interfaces, navigate apps, and carry out multi-step digital tasks. This puts Gemini more directly into the fast-growing AI agent race, where models are expected not just to answer questions, but to do things on a user's behalf. The Flash branding matters too. Google is positioning this as a faster, lighter model tier, which suggests it wants agentic features to be practical, not just premium. For developers, that could mean cheaper automation for repetitive workflows. For businesses, it raises fresh questions around permissions, auditing, and reliability. Ever heard of an AI agent? It's software that can take actions, not just generate text. Think clicking buttons, filling forms, or checking multiple apps to complete a task with limited human guidance. We're getting closer to the day when "I'll handle it later" becomes "my AI already did it," which is helpful and slightly unnerving. Security. The push to secure the future of AI agents. As AI agents gain access to internal tools, enterprise systems, and sensitive workflows, security teams are moving beyond basic chatbot safeguards. The latest roadmap language around securing AI agents emphasizes layered controls, traditional access management, policy enforcement, and real-time monitoring of what agents actually do once deployed. That matters now because agent risk is different from model risk. A model that says something wrong is one problem. An agent that touches payroll, customer records, or source code is another. Companies are realizing that identity, observability, and rollback mechanisms need to be built in from the start, not added after a breach or compliance scare. Ever heard of real-time monitoring for AI? It means tracking an AI system's actions as they happen, so suspicious behavior, bad outputs, or unauthorized access can be flagged and stopped before damage spreads. It's a little like giving a new intern a badge, but also making sure someone notices if they wander into the wrong room. LLM Gemma 412B arrives as a unified multimodal model. Google's Gemma 412B is being introduced as a unified, encoder-free multimodal model designed to handle different types of inputs without relying on separate front-end encoders for each modality. In plain English, this is about simplifying how text, images, and potentially other data types are processed inside one model family. Why it matters. Smaller, more efficient, open-ish models are becoming strategically important. Not every company wants a giant frontier model. Many want something deployable, tunable, and affordable. A 12 billion parameter model can sit in a useful middle ground for research teams, startups, and enterprise pilots. The encoder-free angle also signals a push toward architectural simplicity and possibly lower serving complexity. Ever heard of multimodal AI? It's AI that can work across more than one type of input, like text and images together, instead of treating each format as a completely separate problem. For everyday users, this is the kind of progress that eventually makes AI feel less like a text box and more like a genuinely observant tool.
Cloud. NVIDIA and AWS deepen their AI production push. NVIDIA and AWS are expanding their collaboration around production-scale AI, with emphasis on low-latency inference, vector search, GPU price performance, and infrastructure that can scale without turning operations into a nightmare. The practical pieces span Amazon OpenSearch and Amazon EC2, where enterprises are trying to move from prototypes to durable, revenue-generating systems. This matters because the cloud AI market is entering a more disciplined phase. Customers still want top-end GPUs, but they also want cost visibility, reliable deployment patterns, and less engineering friction. NVIDIA benefits by staying central to enterprise AI stacks. AWS benefits by making its cloud harder to leave once workloads are optimized around these tools. Ever heard of vector search? It's a way to find information based on meaning instead of exact keywords. AI systems use it to retrieve relevant documents, memories, or product data before generating an answer. Basically, this is the part of AI nobody brags about at parties, but it's often the difference between a cool demo and a real product. Smartphone. Google speeds Gemini Nano on Pixel with frozen MTP. Google says it is accelerating Gemini Nano models on Pixel devices using frozen multi-token prediction, or MTP. The goal is to generate more than one likely token at a time, while keeping parts of the prediction system fixed, improving on-device speed and efficiency without blowing up memory or battery demands. This is a big deal for mobile AI, because phones are where latency becomes personal. If on-device models get faster, users get more private and responsive features without always pinging the cloud. For Google, it strengthens the Pixel story as an AI-first hardware platform. For the broader market, it pressures Apple, Samsung, and Qualcomm to keep pushing local inference performance. Ever heard of multi-token prediction? Traditional models usually guess one next word piece at a time. MTP tries to predict several in parallel, which can speed up generation if the system keeps accuracy under control. In real life, this is the difference between your phone feeling clever and your phone feeling like it needs coffee. Developers. New framework targets auditing machine unlearning. Researchers have introduced a new framework for auditing machine unlearning, the process of making a trained model forget specific data or examples after the fact. This is increasingly relevant as privacy rules tighten and users, regulators, or companies ask whether data can truly be removed from AI systems once training has happened. The hard part is trust. It's one thing to claim a model forgot something. It's another to prove it in a rigorous, repeatable way. That's why auditing frameworks matter. They could become essential for compliance, model governance, and legal defensibility, especially in healthcare, finance, and consumer platforms handling sensitive information. Ever heard of machine unlearning? It's a technique meant to remove the influence of certain data from a trained model, ideally without retraining the whole system from scratch every single time. It sounds abstract, but it connects to a very human question. When you ask for your data to be deleted, did it actually happen? AI. MIT uses LLMs to help robots handle vague instructions. MIT researchers have developed a two-model approach to help robots better understand vague human instructions and ignore irrelevant details. One language model helps clarify what the user likely means. Another helps the robot focus only on task-relevant information. The target use cases include homes and factories, where instructions are often messy, incomplete, or casually phrased. If language models can bridge that gap, service robotics becomes much more practical. Ever heard of task relevance in robotics? It means separating the details that matter for completing a job from background noise. Humans do this naturally. Robots usually need a lot of help. Honestly, if a robot can understand the blue mug by the sink, not the one on the table, that's when home automation starts feeling genuinely useful.
Hey, Nova here.
If there's one thread running through today's stories, it's this. The AI race is shifting from raw intelligence to operational maturity. Better chips, safer agents, faster phones, more practical cloud stacks, more accountable models, smarter robots that can deal with how humans actually talk. That's where the next wave of winners may emerge, not just in model rankings, but in products people trust and keep using. And that also means the tech market is broadening. It's no longer just about one lab or one model. It's about the whole ecosystem learning how to deliver AI at scale without breaking budgets, privacy, or common sense. All right, catch me again tomorrow. Have a great day out there.